Next up in the VMware Explore Hub Theater, please welcome the Senior Staff Engineer at VMware Tanzu, Davanum Srinivas.
Hi, good morning, everyone. Thanks for coming in early for this talk, lightning talk. Today, I'll be talking to you about some of the community work that I've been doing and VMware is involved in, and try to walk you through things that happen behind the scenes. You all know that Kubernetes is, how many times have you all heard about Kubernetes in the last couple of days, right? So you've heard about it a lot. Usually you end up thinking, oh, it's an open source project. When there is a release, I'll start using it. But then what happens behind the scenes? How does the release get made? How do people work with each other? What are the community groups that are out there that make things happen behind the scenes? That's what I'll give you a sneak peek so that you have an idea of, what do we do? So who am I and why am I here talking to you? So my nickname is Dims, so you can just call me Dims. There's a few people here that I recognize. Hi. So I've been associated with open source projects for a very long time, Apache Software Foundation, and then OpenStack Foundation, and things like that. So, open source puts food on the table for us. So it's easy to find me on the Kubernetes community Slack or the CNCF Slack or on Twitter. In terms of various hats that I wear in the community, one is in the Kubernetes steering committee, and that's 7 of us trying to figure out what is the right thing to do for the Kubernetes community as a whole. I also participate in the CNCF TOC, and TOC is technical committee at the CNCF level, and we end up overseeing most of all the projects that are there in the CNCF. So some of the obvious things that you know about Kubernetes is, you can run it across multiple cloud providers. It's general purpose. We meet the users partway. We try to make things easy for them. We try to make things flexible, extensible, automatable. So those are all the things that you have come to expect from us at Kubernetes. And we do have some community values as well. When we are taking a decision, when we are thinking about a problem, and when we are thinking about how to go about doing certain things, there are some values in the community that we have defined that we go back and say, hey, does our action take the values into account? For example, automation over process, right? Having a community over product or company. So those are some of the obvious things that you know. And the values also help when people come to our community. We point to them and say, hey, these are the things we look from you when you participate in the Kubernetes community. And this is essentially, we lay down the law, so to say, right? So the way to look at this CNCF, LF, Kubernetes communities goes like this. So the overall legal entity is a Linux Foundation. Under Linux Foundation, there are multiple foundations, including the CNCF. And the TOC takes care of all the projects in terms of hey, there's a new project coming in, let's throw it in the sandbox. When the folks in the sandbox feel that their project is ready, they move on to incubation. And then when they do well as a community, and also as a technology, then we promote them to graduated projects, right? So Kubernetes is one of the projects under CNCF. And the Kubernetes steering committee essentially interfaces with CNCF for all the things hey, we need money for running CI/CD systems, for example, right? So the Kubernetes project ends up talking to the CNCF, and then the CNCF will allocate the money and work with cloud providers and things like that. So within Kubernetes, what do we do? So within Kubernetes, the Kubernetes steering committee essentially works with groups of people who come from different backgrounds, right? There are people coming from storage. There are people coming from the runtime side. There are people coming from networking. So what we tell them to do is, hey, you want to do some networking work in Kubernetes. Here is what you do. You write a charter to list the kind of things that you want to do and how you're going to work, and the steering will kind of like bless it, and off they go. You get repositories to do all the work in. You essentially have leadership positions. You have chairs and technical leads and things like that. So if you see, we have a lot of these special interest groups for architecture, contributor experience, docs, release, and so on. We also have some groups that go across, like testing is one good example. And we also have things that go vertical as well. So this shape of all the SIGs and working groups essentially help us do the work on a daily basis. And I want today to talk a little bit about the SIG architecture, what is it involved, and how they do their work. The best way to think about this is the SIG architecture is the backstop. When things are not formulated, it's not in any of the charters for the different SIGs, they end up going back to SIG architecture and say, hey, SIG architecture, where do I work on this problem? Who do I work with? And what is the kind of outcome that you would like to see from us? So that's where SIG architecture comes in. So we take care of what do the APIs look like, design principles, deprecation policy, how do we create enhancements, and so on and so forth. So on a daily basis, so we meet every other week in the SIG architecture. We have agendas proposed by the community, and we go through the list of items that are there, and so on, just like any other open source project. So there are some subgroups, some sub-projects within Kubernetes, within SIG architecture. One is about conformance. Say, when you come to us and say, hey, I want to move my workload that is running in EKS and move it to AKS or something else, right? So how do we know that you get the same experience between the two cloud providers? Or you want to instantiate your own Kubernetes instance in bare metal or some other cloud. So the conformance tests are basically, gives you the signal that if you run it here or there, you'll get the same kind of output out of your workload. Your workload can expect the same behaviors when you're running in different clouds. So we also have an API review process so that each SIG doesn't have its own thing, and we try to consolidate and give them guidance on the best way to do APIs and such. So we also have enhancements. So enhancements are very critical because most of the people who come to Kubernetes really want to add some features into Kubernetes, right? So we tell them, we have a process for enhancements, and here is the process that you need to go through. And you start by taking the template for the enhancement process and start adding stuff in there. And you need to get sign-offs from the multiple special interest groups that are out there that are related to the work that you're trying to do, and so on. So deprecation is also very important. Deprecation essentially gives a way for the Kubernetes community to say, hey, this feature is no longer very useful. Let's get rid of it. And here is we get rid of it over a period of time. And we send out signals through change logs. We send signals out through blog posts and things like that to say, hey, if you're using this feature, then you need to come and talk to us because we are going to get rid of it in a few releases down the line. So the deprecation becomes very important. And production readiness is even more important because how do you know if the feature that you're developing is ready for production. Does it have enough monitoring, logging, and such that is baked into the feature? How do people know that the feature is actually working, and if anybody is using that feature or not, so that you can turn things off as needed? So production readiness reviews becomes important there as well. So these are 5 subgroups that exist within SIG architecture, and they have their own cadence, they have their own meetings, Slack channels, and so on. So what are the other kinds of issues that we end up dealing with? Things fall through the cracks. And when things fall through the cracks, then the SIG architecture meets and to figure out, like, OK, what do we do now? Because we haven't written down any guidance when we face this kind of a situation. So we handle inconsistencies, escalations, and things like that. We do have a mailing list. It's easy for you to join the mailing list, and once you join the mailing list, you get access to all the Google Docs that we end up using on an ongoing basis. So we talked about this a little bit. And yeah, review process. So for each of these, we do have a review process, and we have documented the review process so that people who are coming to us with an enhancement proposal, we can tell them, here is a list of things that you need to go through. It makes it easy, and we consistently do the same thing for every given enhancement process or deprecation or API reviews and so on and so forth. So one simple example is code organization. So in code organization, what we end up doing is, how do we make sure that things are, how our code base is neat and tidy, for example, right? So are all the different groups ending up using the same logging, structured logging, for example, right? Then what is the policy for generics? When Go, latest version of Go came out, we had to end up writing down a policy for, hey, you can't start using generics at your whim. Here is how you should start doing it. Introduce things into, say, libraries first, and then when you know they are working fine, then you go to the main code base and start using those. The other thing that we end up doing here is licensing. So because we can't, there is a set of licenses that are approved by CNCF for use in the different projects. So we try to make sure that all the dependencies that we pick up are within the set of approved licenses and so on. And what we also end up trying to do is, if there are multiple groups that are trying to use different libraries to achieve the same thing, we kind of like go and figure out like which of these libraries are sustainable, which of these libraries have ongoing releases and that we can rely on, how are their security processes, and look at all those things and make recommendations so that we can line up all the SIGs and the working groups towards the same set of dependencies. Enhancements. We touched a little bit about the enhancement process, right? As I said earlier, most of the people come to us saying, hey, here is an enhancement. And they usually open issues, and we redirect them over to this enhancements process that starts with the template, and we walk through a little bit about what is inside that. So the enhancements are also important because a lot of features start as alpha, and then they need to go to beta and then GA. And similarly, that is for the promotion. And then on the other side, when people stop using something or something is not working the right way, we go through the deprecation process, and that is all covered in the enhancements as well. The enhancements process also gives the SIG release an idea about what are the kind of things that people want to add to that specific release. For example, we just released 125 of Kubernetes a week or so ago, and the release managers ended up figuring out what are the things that we need to promote through blogs, through social media, through change logs, and all the different varieties of things. Like one example is we ended up promoting a feature called C Groups V2 into GA, which means that anybody in the community can use it for their production purposes, and we essentially mark it as approved, and for general use. Earlier, when it was in beta or in alpha phase, we were telling people that, hey, we just started doing this. We don't have enough test cases. We don't have enough CI testing. So, use at your own risk. It kind of works, but then when it actually the feature is promoted to GA, then you know that you can use it without any problems as such. The conformance testing. So one of the important things here is making sure that the way Kubernetes works is consistent over across cloud providers, across releases, and that's what we do by conformance testing. So even, for example, when I was talking to you about a feature going to GA, what I was telling you about was from the view of, hey, from end user saying, okay, I see it in the change log that C Groups V2 is ready to be used by everybody, so I'm going to go use it. But how do we make sure that it is actually ready to be used? And we do that by adding conformance tests on the back side to ensure that all the people who are using certified versions of Kubernetes, whether it is EKS, AKS, or Kubernetes using different installers, all of them have to go through this conformance certification program for them to be able to use the logo and the name from CNCF, right? So, and we do write the tests to make sure that it actually works on all those different providers of Kubernetes. But the deal here is we are not 100% in terms of coverage of all the APIs, and it's an ongoing process, and we are trying to, when there is a new feature that is being coming up right now, we actually insist on making sure that it comes with enough testing that can be added to conformance. But there are some older APIs which don't have those tests, and we are working with a set of people who are adding these tests for all the things that we had back before the conformance program began, essentially. Production readiness reviews, we talked a little bit about it. We want to make sure that there is enough monitoring, enough documentation on how to switch things on and off. How do we roll things out? How do we scale it? And how do we make sure that it is secure as well, right? So that is the questions that we end up asking the people coming to us with a feature to say, did you think about all these things before coming to us? So we ask these questions because over a period of time, we figured out that, hey, some people will show up with a patch, and they'll throw it over the wall and say, hey, this works for us. This works in my environment. Please, merge the patch. And we are like, no, we can't be doing something that is specific to just you. We have to make sure that it works for everybody. So we have to make sure that you answer all these questions to see if it is actually usable by the majority of the people that use Kubernetes. So I won't talk too much about this. So what we have done over a period of time is we've given extension points to the different, when somebody comes with a feature, right? The first question we ask is, does this code need to be merged into the Kubernetes tree fully? Or can we give you an extension point where you can actually do the things that you want to do, but the code doesn't have to live in the Kubernetes repository, right? We try to do that because, there might be some need by, a set of users that want to do something specific in their environment, and we don't want to introduce that piece of code to everybody in the Kubernetes community. We try to set a high bar on the things that go into the Kubernetes code base as such, so that we make sure that by doing this, what we end up doing is we increase the number of people who can use these extension points and who can develop things that they want in their own environment. Simple examples that we have seen over the period of time is, how does CRDs work in Kubernetes? CRDs are, custom resource definitions, and most of the people that are developing on top of Kubernetes right now are using the Kubernetes API, and they are trying to expose their own resources as, the same as the Kubernetes API as such. So we have scheduler extension, kubectl extensions. We have pluggable cloud providers, secret management, and things like that. And we've done this over a period of time for a specific reason. And the specific reason is we don't want all that code to live within the Kubernetes repository itself. And we want to make sure that people outside of Kubernetes, they can iterate at their own pace, right? And if something becomes really popular, then we can fold that into the Kubernetes code base. How can you participate? So you can come to any of the sub-project meetings or the main meeting. We have mailing lists, we have Slack. We don't bite, so come and say hi to us. And find something of, typically the way it works is like, you should have a need for a specific thing, and then it is more easy for you to interact with us because there is something common to talk to you about. Speak up, help with issue triages and PR reviews and documentation and things like that. And you can be a valuable contributing member to the community. Thanks a lot. I'll be hanging around here today. So if you have other questions on like either the community, the Kubernetes community, or the CNCF, or other projects in CNCF, please come by and talk to me. Thanks a lot.
Hello. Well, Alex, we get to kick off.
Yes, we do. Gosh, it's Wednesday, and I got some sleep last night, so
that's good.
I'm full of energy. And I had some poached eggs this morning.
Oh, did you get any cream sauce on top?
No, I had a salad instead of potatoes.
Oh, so healthy. That's that.
I don't always do it that way.
Yeah, yeah. Well, also for anyone watching the video, Alex and I coordinated our shirts today.
Yes.
He's coming in at matte and I'm glossy. So we thought we'd.
That's a good way to put it. Yeah.
Yeah. Well, thanks for that talk. That was nice. I think like all of us, we've been around for a while, I'm assuming, and seen many like iterations of foundations and things like that. And I think like digging into the operational stuff is like actually interesting to see how a foundation works, and then going up higher, right? Like the first thing I was interested in talking about is like, what do you think like the Kubernetes Foundation, or not the CNCF, whatever, like has like learned about incrementally improving how foundations work, right? Like what's kind of the new, just to kind of explain the context, right? So I think the furthest back foundation I can remember is like the ASF, right?
Yep.
And then, Eclipse was after that, and then OpenStack, and there's many other ones. And
Yep.
each of them kind of like builds on the one past it. So I'm curious, like, when you look at the CNCF and Kubernetes work, like as y'all are on the board, here's a new thing that's going to be awesome that we're going to do.
Oh, that's funny that you asked that. There's a bunch of us who float between the foundations, right? We started work in Apache Software Foundation, and then we moved on to, I've done some work in Eclipse Foundation as well, but more in the OpenStack Foundation. And we talk to each other all the time, So we keep asking each other, hey, what is a new thing that you're trying? Looks like we need people in testing, or we need to set up some infrastructure for testing.
Right.
What did you do? How did you do it? And what worked? What didn't work?
Yeah, and to interrupt you, that seems like one of the major innovations of the OpenStack Foundation is that like this testing and conformance thing is kind of a big deal.
We literally picked it from them.
Right.
And in fact, when I started working at CNCF and Kubernetes community, I was known as the OpenStack guy, but no longer, right?
Right.
Now I'm the Kubernetes guy.
Yeah.
So, we tend to embrace the people as they come in as well.
Right.
So
what's a practice that you think is kind of like an incremental improvement in the foundation world that y'all are doing?
So right now, we are all talking about sustainability. How do we make sure that things are there for the longer run?
Right.
Because as Kubernetes has a few years under its belt, and now we have to figure out how do we make sure that it works for people who are not 9 to 5 on the West Coast, and it should work for people across the globe, and it should work for people who are working part-time, who are students, who want to contribute. I joke about saying in a year or so, Kubernetes is going to be a code base which has no spelling errors and grammar errors because.
So I want to challenge this a little bit, okay? So sustainability, right? That can lead to a lot of mediocrity too, can it? And how do you continue to take risks that are really important and making decisions that are really important? Because, you could have a lawn and you put fertilizer on that lawn all the time. And but someday, you may have to change it up. You may have to dig that lawn up. You may have to put in some bushes.
Absolutely. So the way we do it is through controlled experimentation. And I'll give you one example of how we do that, right? So, 2 years ago, there was a group of folks in the community that were interested in, how do we do batch processing, right? How do I schedule if I want to have a ML or an AI job, which needs exactly 25 pods, spread across the nodes. And it's a binary thing. You do all 25 or you don't do any of them, right? So they were interested in that kind of challenge, and we kind of added the scheduler extensions to give them, hey, go forth and experiment and come back to us with your learnings. Now they have it ended up adding projects like Volcano and a few other things, right?
I know Volcano.
Yeah, now they are coming back to us to say, hey, we want to have a work group in Kubernetes and a work group in CNCF level so that we know what to do and how to do it right. What is the minimum set of things that we need in the base layer in Kubernetes itself? And then...
Okay. So let's take this to another level then. So what if there are real poor decisions maybe that were made based on a set of precedents that really had an impact on the core?
I can give you two. One is recently we are in the process of deprecating what we call pod security policy. And the other one is completely removing Docker shim that we had within the Kubernetes repository. Those were two big mistakes. In terms of the Docker shim, it slowed us a lot, especially because we ended up defining the CRI extensions, and we still had this piece of code that was within the Kubernetes community, and it was slowing the work that was being done by Signode in terms of adding new features, so we had to get rid of it. The pod security policy was really hard for people to use, so we ended up redesigning a new set of resources that is easier for people to understand. We wanted to make sure that the 80% of the use cases are covered with the simple stuff, instead of somebody using a really complicated pod security policy. They have something easier to work with.
So and then my last question for this part of the show.
Okay.
So what are some of the issues in the core right now that are just not working, like pod security policy? They're always going to come up.
Yeah. So this is one of the reasons why we did the annual review. This is the second time we did the annual review, and we have enumerated a list of problems that are there in the community, whether it is people-oriented, whether it is technology-oriented, and things like that. And you when you read that, you will get a sense of like, hey, here is where we need to invest in, and here is where we need help. So simplest of things, testing, right? What we have found is there are people who come to different SIGs and want to work in those SIGs and want to do well in those SIGs. But what we are losing in the process is we don't have people who can work across the SIGs, right? So when we run into flakiness in the CI jobs, we don't know who to talk to, right? And the number of people who can understand things that happen across the SIGs is very few. And that is where we need investment in. And we have to make things better, easier. In fact, this 125 release was the release where we had the least amount of flakiness. So the CI signals that we were getting out of the SIG release folks was, the green thumbs up all the time, and we were very happy. We've been struggling with flakiness in the CI jobs, and people just end up doing a retest of all the jobs. And frankly, that costs more money, right? Like if you have a single PR and it runs a set of jobs, and if it passes, you have good signal. But if you have to retest 10 times, then you're essentially increasing the cost of your CI.
You need some anti-flakiness, like some I don't know, anti-dandruff shampoo for the organization.
Yes.
Yeah, that's tragic. That's what comes to mind. But so you covered a little bit, and we've talked a little bit about introducing new things into the overall project. And we talked a couple days ago with Lucas from Loft. And so one of the discussions we had with him is like, between the more open source community stuff that you do, and then as you go up into Loft, like what you do. Yeah. Like one of the things I think we're interested in is where is that cut line of like, we're not going to do that. or to put it in a more positive way, that's a great thing for someone to add to the community on their own. The overall ecosystem, I'll use that word, right? And so like, and the reason I asked that, I'm curious, but especially us being at VMware, and everyone else is interested in like improving it for developers. Yeah. And so there must be a line somewhere where you're like, well, we're not going to do actual code stuff. So like, but where is that level where you feel like the kind of the CNCF and the Kubernetes ecosystem is like, we don't really do that. Like that's someone else's thing.
Yeah. So I'll give you one example where we have a line that we have not crossed yet, which is how do you stitch multiple Kubernetes clusters together?
Right? Oh, right.
That's one example where people are innovating in the ecosystem. There are startups, there are different projects. Loft has the vCluster thing, for example,
vCluster,
right? So we did 2 experiments in that area, but we ended up giving up on that idea. For example, we did a kubefed 1 and kubefed 2 Kubernetes federation, literally. And those were experiments that we tried, but we did not bake those things into the Kubernetes code base itself, right? We kept it outside, but we were innovating. We were trying something out, and we didn't like what we saw, and we kind of like gave up on it. So
Why'd you give up on it?
Because we didn't like the APIs, we didn't like the way it worked. So
what did you not? I keep digging a little bit. What did you not like about the APIs?
Like kubefed v1, right? That was a kind of like, I know Solomon is here. It was like Swarm, right? You have the same API, but underneath you have something else. So that was one experiment that we ended up trying. And that was not a good choice for us. So we said, okay, fine. Let's remove that. Let's try kubefed v2, where we'll reimagine the APIs. But that didn't seem enough for us. And the way we end up figuring this out is nobody's using it, right? There's very few people using it, and we are not getting enough feedback from the people saying, hey, we are using it. If you can make this small thing better, then, if we don't have that feedback loop coming in from the community, then it means that it's not of much value to people in the community, and we stop doing, things where hey, one vendor is driving it, and so we are adding some code, and then, but if you see it's a dead end, then we stop, we deprecate, and we get rid of it in a new release.
So, like another topic that I talk with analysts and press and users, companies that use Kubernetes, and like maybe it's because I'm from VMware, but they always like to throw out like lock-in and things like that, and you know, like how like that is like if we want to make sure that we have you probably remember Simon Phipps, not that he's gone, but like he had this great phrase, the freedom to leave. Like that's really what, you know, his theory was, that's really what people are looking for with things. And like I mean, how at a foundation level, like how are y'all thinking through, like we want to make sure that we have that freedom to leave, that like how do you engineer that into? Because I mean, you know, obviously it's like, oh, it's open source, right? But like there must be a lot more thinking put into it as far as the entire ecosystem and how it all works together.
You know, some of the obvious answers there is like we make sure it's Apache license, right? And one example of freedom to live is, you know, Grafana Labs. They were working on a project called Cortex in the community, and they said, okay, we are not getting the kind of engagement that we are getting from that we need, and we are trying to do all the engineering by ourselves. So you know, out we go, right? So they ended up doing open source, single vendor open source called Mimir or Mimir. I don't know exactly how to pronounce it. So you know, now they are off doing their own thing. And that's the same for anything that I've listed out as extensions, right? Like, you know, I listed a whole bunch of extensions. And like, take the CNI, for example, or the CSI. How many vendors do we have for CSI? How many vendors do we have for the CNI, right?
A lot of them.
Yeah, exactly. And those kind of things were baked into Kubernetes right at the beginning, and then we kind of like kicked them out saying, hey, go explore the things that you want to do, and you don't have to talk to us. You don't even have to, like, you know, unless you run into a problem, you don't even have to do anything with us, and you can innovate on your own, right? So you have Antrea from VMware, we have Cilium, we have, you know, so many other projects. vWorks had a project too, right? Like, so VNet. So that is an example of like how we are unblocking the innovation, you know, in the community.
So I just have a last question for myself that I'm curious about. What gets you so excited about the work that you do? What is it that impassions you to get up there and like give this very thorough and deep explanation of SIGs?
The people, right? I look forward to talking to all the friends that I made over the years, right? And it's not even necessary that they are doing things with me right now. You know, the other day I was talking to Henry Yandel from AWS, right? And the last time I spoke to him was like 15 years ago, but it felt like yesterday that I talked to him, right? So it is the people that bring you back to the work, and it's the like software happens when people get together, right? And sometimes I also think that the people problems are more difficult than the software problems as well, because wearing the different community hats, we've seen, you know, issues, people related to people, and those are harder to solve than, you know, the software stuff. So it is essentially, you know, the people that end up making things good for me.
So you probably know the dates better than me, so you can fill it in, but KubeCon North America is coming up. That's in October?
Yes.
Yeah. Good enough.
Yeah. Third week, I think.
Yeah. And I mean, over recent years, like, that conference has grown incredibly. I mean, it's over 10,000 people now, something like that. And so, for people who want to go to that, what's your advice for, like, you know, you can't talk to 10,000 people, or like go to all the sessions. Like, like how should someone like plan out having a good, useful time at that event at that scale?
So what I would try to figure out is like, what do you want out of it, right? So, for example, when I go to KubeCon, I go there to meet my friends, right? Like, I'm not really interested in the sessions as such, but I go there so that we work with each other, for a very long time. It's like a couple of times a year when we can actually get together, right? So that is important to me. But for example, we coach and mentor students that are coming to KubeCon, and we actually have scholarships for people to come as well. What I tell them is like, plan ahead. Figure out which sessions you want to go to, figure out who do you want to talk to, make an effort, and come up with a topic that you can talk to somebody about so that you can have a conversation and they will remember you rather than just doing a handshake and walking away. Like, you're not going to remember the face or the name, but if you talked about something, then you'll say, okay, I remember that guy because, or that girl because, we talked about, how to do something better in this part of the code base, and that becomes something that you can follow on once you go back from KubeCon as well.
So here's another thing that I would ask. What do you want to know? What are you trying to learn? So then what do you ask? What are those questions that you want to ask people? And write those questions down. Because then you can find those, then you can talk to those people. And when you're talking to people, you might just think of a question.
Yes.
It's that preparation. There's also pancakes, apparently. At the
Nice.
Yes.
This is the pro advice from the journalist. Doing your prep work, knowing what you want to talk about.
Thank you very much, Michael.
And I think, I haven't really thought about that as an aspect. It's sort of like organically evolves if you go to enough conferences. But that is a good idea I like your idea of people remember a topic.
Yes.
Chances are they remember a topic more than a person.
Correct.
For better or worse.
Yes.
But that is good to kind of prep out, like, here are things I want to talk about and find out about, and the specific questions that I ask people, because otherwise you just kind of ad hoc float around with things. So that
it's almost like, and if you have the the interest, write something down. Like write a blog post even.
Absolutely.
Write a series of tweets saying, these are the questions I have. I'm looking to try to get these questions. So that's a lot of nice prep work you can do beforehand. And it helps you kind of with your profile. Not everyone wants to do that, but it can be a way.
You do it on the flight over. I mean, you're probably seeing all
the flight.
Are you really going to watch another Marvel movie? Like what?
No.
Yes.
All right. Well, great. It was really fun talking with you and getting that kind of overview of the internal workings of how things float around there. So we
thank you,
appreciate it.
Michael.
We'll see you around.
Thank you, Alex.
You're welcome. Thank you.
Thanks.
Bye.
Bye.